Hello guys, Assalamualaikum warahmatullahi wabarakatuh. Welcome back with us from Group 2 in the chemistry lesson. So today, I and my team is there Khaliza, Annisa, Jihan, Azhara, and Nida, Sayyidah. We would like to presentations about the internal structure of atom. Before that, I want to remembering about the atom is. Like we know, atom is the smallest unit of the matter. You know what is the matter? Right, it's like this. Is it the examples of the matter? Is it the pencil that has it's made of the wood, right? And then it has the more atoms, like atom, and they completely with the matter. And you know, the atom is not only have the one structure, it has the three structure. But what's that, right? Let's start with the explanations. Jihan, could you explain us about the structure of the atom?
Okay, I will explain about subatomic particles. So atom can be split into subatomic particles. And the first one is the electron. First, Millikan's oil drop experiment and Thomson cathode tube was used to measure the charge of the mass ratios for the electron. And then the electrons are in the space outside the nucleus of the atom in orbits. And then electrons carry a single unit of negative charge or 1 minus. And the second one is the proton. The proton is from the Greek word that proteus, meanings of first importance. And second, a mass spectrometer was used to measure the charge of two mass ratios of positive ions. And the protons are inside the nucleus of the atoms. The protons carry a single unit of positive charge or 1 plus. And the third one is the neutron. The neutron have no charge and electrically neutral. And then the neutrons are inside the nucleus of the atom, except hydrogen.
Oh, so the atom has the three structure. Is it the electron, proton, and neutron? Is it? But that interesting to me is about the experiments that improve about the electron, proton, and neutron. Could you explain us about that experiments?
All right, Khaliza, next please. Okay. So we can see here on the picture 1 and the picture 2, it experiments was used to measure the charge to mass ratio of the electron. And the picture 3 is called the mass spectrometer, was used to measure the charge to mass ratio of positive ions or protons.
Wow, so very cool. So the atom has the properties, Jihan?
Yes.
What is that?
Okay, so we can see here the properties of the subatomic particles. The particles of electron has a mass that 9.1093897 times 10 to the power of minus 28. And electron has 1 minus electrical charge. And this is the symbol. So the second one is the proton. The proton has a mass that 1.67262231 times 10 to the power of minus 24, and it has 1 plus electrical charge, and this is the symbol. And the third one is neutron. The neutron has a mass that 1.674926 times 10 to the power of minus 24, and it has a 0 electrical charge or neutral, and this is the symbol.
Okay. Wow. I already know about the proton and neutron. It has the same mass. is 1.67. But the difference of the proton and neutron is only in the electrical charge and the symbol. The proton has the +1 and the neutron is 0. Wow, it's interesting. So I've heard about the nucleus. It has the relation about the atom and the nucleus. Nida, could you explain us?
Okay, thank you, Fani. I will explain about nucleus. Next. Okay, thank you, Fani. Now I will explain about nucleus. First, the positively charged central core of an atom consisting of protons and neutrons. Second, protons and neutrons are sometimes called nucleus. Third, in a neutral atom, the number of electrons must equal the number of protons. Okay, next slide. Okay, now the atomic number. And now atomic numbers and mass numbers. First, the numbers of protons is called the atomic numbers. The symbol is Z of the elements. Each element has a different atomic numbers. Second, isotope of an element have identical atomic numbers but different numbers of neutrons. In more modern terms, an element can be defined as a substance whose atoms all have the same numbers of protons in their nucleus. Third, the numerical sum of the proton and neutron in the atoms of a particular isotope is called the mass number. The symbol is A of the isotope.
Oh, so is it the reason why, why the proton and the neutron has the same mass, right? So because the proton and the neutron in the same class in the core, in the central core of the atom, and the electron is around them. And it's interesting about the atomic number and mass number. Atomic number we can write with the symbol of the Z, and the mass number we can write with the A symbol at A symbols. How about the isotopes? Isotope has this. It's possible to has the same number of the proton, right? And we can have the isotope. It's called the isotope. How about the writing in the Z and A, Nida, in the atomic number and the mass number for the atom?
Okay, for writing, this is the writing of the atom. A is number of protons, isotope mass number. I'm so sorry. I explained wrong. So A is number of proton plus number of neutron. And then Z is atomic number of proton, or we can call it number of electron, because number of protons equal number of electron.
Oh, I see that. So we can write Z is under and the A in the top.
Yes.
Okay. How about the relative atoms? I've heard that when I study about the atom. Could you explain us about that?
Okay, I will explain about the relative atomic mass of elements. Individual atoms are much too small to weigh in the traditional manner. However, the relative masses of the atom of elements can be determined provided we know the ratio in which the atom occur in a compound. That is funny.
Okay, so I will explain about why 12 carbon becomes standard for atomic mass scale. First, one atom of this isotope is exactly 12 units of mass, which are called atomic mass units. Some prefer to use the symbol AMU for the atomic mass unit, The internationally accepted symbol is U. First, one atom of 12C has a mass of 12U exactly. Second, 1U equals 1. Third, 12 the mass of one atom of 12C exactly. Second, chemists generally work with whatever mixture of isotopes that occur naturally for a given element. Because the composition of this isotope mixture is very nearly constant regardless of the structures of the element, we can speak of an average mass of an atom of the element average in terms of mass.
Oh, I see that. So the carbon 12, it has the exactly 12 atoms.
Yes.
How about the isotope of the carbon?
Okay, the isotope of carbon, these are 3 isotopes of carbon, 12, 30, 13, and 14. And the percentage abundance of 12 carbon is around 98%, and for 13, the percentage abundance, it's around 1%, and for 14, less than 0.1%.
Well, it's interesting. I see this, the proton and neutron in the core centers of the atom. It has the different number, right? It has the 6 proton and neutron in the carbon 12 and the carbon 13. We have the 6 proton and 7 neutron, and the carbon 14, we have the 6 proton and 8 neutron. We can calculate this with the formula of the Nida said before, right? In the Z and A, right? But Khaliza, in the system periodic the chemistry, I see about the hydrogen. How about the hydrogen? What is the mass and the isotope of the hydrogen?
This is isotope of hydrogen. You can see that there is 2 types of isotope. First is one hydrogen has mass around 1 mol, and then the 2 hydrogen has around 2 mol, has mass around 2 mol, and then the percentage abundance, the 1 hydrogen is more than 2 hydrogen. You can see at the percentage of abundance.
I see that. So we can more find the hydrogen one because it's the percentage of abundance. So so more, right? In the 99.
Yes, exactly.
99.85. Okay. And how about the average of atom? You said before in the slide, right?
Okay, so I will explain about average atomic. So there is a relation between average atomic masses and isotope abundance. So example of a compound was analyzed, and from the formula of the substance, the relative atom masses were calculated. These were then adjusted to place them on the unified atomic mass scale. The average atomic mass for any element can be calculated by multiplying the percentage of each isotope by its mass and adding the values together.
Oh, I see that. So when we would like to average atomic masses, we only multiplying the percentage of each isotope by its mass and adding the values together. I see that. I so got it about this. So thank you, Khaliza, thank you, Nida, and thank you to Jihan. Maybe is it the ending of our presentation, right? So for you guys that still confused about this matter, you can type your question in the comment sections below, right? So maybe that's all for us. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.